Now, this illustration deals with sizing a junction box based upon the same size conductors. Now, we're not using necessarily 314.16b1 through b5 and table 314.16b in this case, because the number of conductors in the box are so many that the table will not provide the appropriate size box to house these conductors. Now, notice we use our table 314.16a or b when the conductors entering the box would be number 6 or smaller. Once the conductors are number 4 or larger, it's the size of the conduit that determines the size of the box. You'll have a straight pull, or you'll have an angle or U-pull. Now, if my memory serves me right, I believe that's 314.28. It's either 314.28 or 314.27, but my memory's failing me a little bit on that, but I know it's one of them. So keep that in mind. So the question is, what size junction box? Not device box, not octagon box, not square box, but what size junction box is required to contain 4 raceways with 8 number 12s each and 2 raceways and 4 number 12 AWGs in each. So now, based upon that information, we'll go to step 1, and we'll still be counting the conductors, just like 314.16b1 and b5. The only thing, we won't use table 314.6b. We have to use the junction box sizes, which I previously quoted to you in the back inside cover of the design book, or get NEMA 250, and they have junction box sizes in that standard. Now, there are 8 number 12s, so you have 2.25 times 8, which would give you 18. That's why the table 314.16b is listed. We got to get these cubic inch ratings. We have 8 number 12s that could be neutral. The top was the ungrounded conductors, and there's 8 of them. We come up with 18. We have 8 number 12s, 2.25 times 8, 18. We have 8 number 12s, 2.25 times 8, we would come up with 18. 4 number 12s, 2.25 cubic inch times 4 gives you 9. 4 number 12s, 2.25 times 4 gives you 9 cubic inches. Now, notice this is including ungrounded conductors, hot conductors, and the neutrals. The MT serves as our equipment ground. Adding all that up, we come up with 90 cubic inches. So we would select from a box chart. As said, we have it in the back inside cover of our design books, volume 1 and 2, or get NEMA 1 250 would give you that. That's not NEMA 1, excuse me, that's misquoted. NEMA 250 would give you these size junction boxes. So using either NEMA 250 or the back inside cover of the design book, where we have these box sizes listed from NEMA 250, you would find a 6-inch by 4-inch by 4-inch would total out, when you do your math, 96 cubic inches. 96 cubic inches will contain 90 cubic inches. So the solution and answer is a 6 by 4 by 4 will house those number conductors. So now, why in this illustration are we using junction boxes instead of the device octagon or square box? It's because the 90 cubic inch is out of range, where you could use one of those boxes with an extension ring like a square box and come up with enough square inch area that you could use that type of box. So that is what this illustration is illustrating.